look at the numbers. This one right here is the number on the second term, right? Look at all the second terms here. This is the first term. Second term, that's 1. Second term, 2. Second term, 3. Second term, 4. Second term, 5. Second term, this should be a 6 if it follows the pattern, right? Yes? Yes. It is. Now the next number is a little harder to get. But we can at least get that first number, right? Now it turns out that you can create all the numbers, and it comes from something called Pascal's triangle. For us, for what I'm doing today, for what I'm about to show you with finishing that problem, I just need this one. That's the only one I need. But I will show you the rest, how to get the rest, because I've come this far. So this was discovered by the Chinese a long time ago, but there's a mathematician named Pascal, last name Pascal, that gets the credit for this. Don't ask me why, all right? But he does. So we understand what's happening with powers. What about the numbers? So I'm going to highlight them, just the coefficients in here. 3, 3, 1, 1, 4, 6, 4, 1, right? You see all the numbers in there? Okay, if you write down just those numbers, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, you'll notice the pattern. And here's what it is. The n numbers are always 1s. Okay, so your first row has one number in it, and so it has to be 1. The second row has 2 numbers in it, but the n's always have to be 1s, right? So that means both of those have to be 1s. The third row, the 2 n's have to be 1s. The number in the middle is the sum of the 2 above it. 1 plus 1 is 2. The next row, the 2 n's are 1s. This number 3 is the sum of the 2 above it. This 3 is the sum of the 2 above that one. Do y'all see the pattern? This one, 4, 6, 4, 1. This one, 5, 6 and 4 is 10, 6 and 4 is 10, 5, and then 1. So what would this one be? 15. This one would be, so I have, this was the 1 and the 5 together. This one right here would be the 5 and the 10, so 15. Plus, what would the next one be? 20. Now I can continue with the powers. X cubed, h cubed. X is coming down, h is coming up. Plus 15 again, that's the 10 in this 5. X squared h to the 4th. One more. 6x h to the 5th. And you could theoretically just continue for the rest of your life doing this, right? You can show off to your friends. You can gather them all around and say, hey, look, I'm going to start doing binomial expansions, which is what this is called. Gather around. Let me show you how brilliant my mind is. Just start expanding away. And if they don't know the pattern, they're just going to be awed by your intelligence. And after you get to about the 100th expansion, you turn around, all your friends are gone, and you're alone. All right. So if this is the case, can you tell me, if I try and expand x plus h to the n, what the first term is going to be? X to the n. Agreed? And the last term is going to be h to the n. We know that. And then that pattern on the second term, 1, 2, 3, 4, 5, 6, this should be then plus 6 was 6, right? 5, 5, 4, 4. So this should be n, right? N is going to be this number, right? This number right here was always n. Yes? Then x, but the power comes down by 1. So how do I write that? X to the n minus 1. Does that not look familiar? Isn't that the power rule formula? It is. Okay, I'm going to keep going. Plus, wait, hold on. I'm missing, hold on, what am I missing there? H. Power came down, h is in there. The h was not in our formula though. Okay, plus the next one. I'm going to concede the number. I'm not even going to try for it. It's something. I don't care. What's the power on x? 2 less than what we started with. So n, take away 2. And now what's the power on h? H squared. And this will keep happening, right? All the way until I get to the end. So I'm going to say plus, in our favorite thing in math, dot, 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 repeating some pattern until I get to the end. Agreed? Okay. With all that said, let me finish the problem that I put a question mark on earlier. So back to proving this. I was trying to find the limit as h went to 0 of x plus h to the nth power minus x to the n. And I'm trying to provide you with the proof of this formula that I gave you that's so great. But I couldn't expand this until I looked at that. And now I understand what that looks like. It looks like this. Limit h goes to 0. It's something like this. X to the n plus nx to the n minus 1h plus something I don't even know, x to the n minus 2h squared plus, and it's going to keep doing that all the way till I get to h to the n. That's this right here. What do I still need to put up here, though, with it? Minus x to the n. This is key right here. Minus this, right? So I'm going to put that right here. Minus x to the n. All of this over h. Do you see it? What cancels? This right here and this one right here cancel. And that's very important because now everything that's still here has an h in it. And so you may factor a single factor of h out, can't you? So if I take an h out right now of the numerator, factor that h out. See, this is the thing. I've been teaching this for a long time. Every single time I prove this, I just love it. I mean, it's just because I know there's like 1 or 2 of you out there that are just like, wow, that is really cool. And that's enough for me. All right. Look, h comes out. What is left up here? Well, the n's here. The x to the n minus 1 is there. I should probably put the n, right? N, x to the n minus 1. I pull the h out. It's gone. On the next one, I said there was a number. I conceded that. I'm not messing with the x, right? So this is x to the n minus 2. I pulled a single h out. Just one of them, which means there's one left, right? So there's an h here, plus dot, 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 all the way down to the last one, which I pulled a single h out, which would make that an h to the n. I took one away, right? So if like that was 10, this is now 9. So take one away. All over h, and these h's cancel. We're going to let h be 0, but how is that going to give me the answer that I'm looking for? What can you tell me about every single one of these, even all the ones in the dot, dot, dot? What do these all have in common? They all still have at least one h, right? So when h goes to 0, everything down here vanishes. And the only thing left is that term right there. Nx to the n minus 1. There it is. That's very nice. All right. So now you may use that, right? I always feel terrible in calculus classes giving formulas without like any backing to it. Just do it. It's good. It works. I unfortunately can't prove every single one of these because we don't have enough time. I would love to do that, but we just can't. All right. Would you like to see the sign one? Good. Good. I'll show it to you. All right. All right, here we go. I'm going to try and prove now that if we take the function f of x is sine of x, we're going to try and show that the derivative of f is cosine x. So I'm using some different notation here just so you can kind of get used to it. Look, I'm calling f this, and I want to show that f prime is cosine x. Okay, well, I'm going to go to the definition. The derivative of that function should be the limit as h goes to 0 of f of x plus h minus f of x all over h, which is the limit. H goes to 0. All right, plug in x plus h. Sine of x plus h. I'm already getting excited about where we're about to go with this. Minus what? Sine x all over h. Now, in the previous problem, the issue we ran into is that we had that x plus h to the n, right? And we had to come up with some general formula for it. Now our problem is, how do we get this? We need an h to go away, right? We need an h to cancel. That's what we've been doing in the past. That x plus h is trapped in the sign.
It's in the argument.
It's in the argument. So you're never pulling an h out, ever.
Split up the denominator.
What do you mean?
Split it up. Sine.
Split it into 2 like this?
Yeah, yes.
Okay, I'm going to write that down. Let me see. I'll follow your train of thought. Let's see where that goes. I'm just going to jot it down just to see if it takes us where we want to go. Sine x plus h, and then over h, and then you want me to go minus sine x over h.
There's a way you can do that funny math like you did on sine junk over junk.
Okay, sine junk over junk. Y'all are on the right track because you're thinking that, but I don't have junk over junk. Remember, the junk has to match.
Yeah.
And only one of these is going to 0. Which one of these is going to 0, x or h? H. Only the h is going to 0.
Is there a way we can get rid of the
Yeah, is there a way? Is there something we can do? I'm going to keep this on the back burner. All right? I'm going to stay looking at this for a minute. Maybe there's something else that I can do with this. What's out there? What's out there that I can do with that? Because that's the problem, right?
Can't you write like sine x plus sine h or something like that?
Yeah, what was that thing?
yeah.
Sine x plus
Yeah. Well,
remember.
yeah, what? You can't remember. What is that?
And then you can take
Okay, so you have a formula sheet, right? Somewhere in pre-cal you had some formula that allowed you to split up sine if you had like things in sum and difference. Yeah, sum and difference formulas. Yeah, see if you can find them on your formula sheets.
Plus cosine x or something?
Yeah, look it up. Look it up. Just so you know where it is on your sheet. What page is it on? I want everyone that has their sheets to be able to find it.
hate those guys.
You hate those formulas?
Really do.
Let me see. It's on your pre-cal one. No? What else? All right, I guess I'll have to get mine out. This is on page,
It's going to be sine.
reference page 2. About 3/4 of the way down on the right-hand side, the addition and subtraction formulas. It says sine of x plus y equals sine x cosine y plus, do they say cosine first? It doesn't matter which way you do it. Cosine x sine y. That formula? And then there's a couple others if you have subtraction inside, and what if this is cosine, right? So that using that formula, but instead of x plus y, we have x plus h. So we could write this as h, 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 right? Like that?
Sine x over h.
We could do that? Okay, so I'm going to rewrite this limit. This is going to become sine x cosine h plus cosine x sine h
Minus sine x.
minus sine x over h. So there's your addition formula, and then there's the minus sine x sitting there. Now you may look at that and go like, wow, that looks so much more complicated now, right? But you do have some good things happening here.
Because you can split that up.
Yeah, what happens if we split that up now?
You go sine x over h.
I'm going to do this, watch. Limit, h goes to 0. Watch the way I do this. I'm going to go sine x cosine h minus sine x over h plus limit h goes to 0 sine cosine x sine h all over h. Okay, so what did I do there? I took these two and put them together over h, right? And then just this one over h, and I just broke it into two different limits.
You break that one too again.
Which one? This one?
Yep.
Yeah, this one, look, if the limit is going, if the limit has h in it, right? Cosine x is totally unaffected,
0, 0 still.
right?
No,
H has nothing to do with cosine x.
that's one. Cosine.
But sine h over h, if I let that limit go, this is your sine junk over junk. They match, and that's going to go to 1, isn't it?
Same thing over there.
So this will turn into cosine x times 1, which is cosine x, right?
That one becomes 0.
Why is that one 0?
Because cosine h over h is 1, and then times sine x is
Careful, careful. Cosine h over h is not going to be 1. Yeah, so let me do one more thing here. This is equal to limit h goes to 0. These two terms both have a sine, x. I'm going to factor sine x and get cosine h minus 1 on top over h. And do you remember, yeah, there was that quiz I gave you where it was like, did I give you the quiz? Well, in the lecture, remember in the very beginning when we were talking about limits, I said these are two limits you need to know, right? One of them was sine x over x. That limit goes to 1. The other one was this one. That limit goes to 0. And if that goes to 0, then sine x times 0 is 0. And so this whole side right here goes to 0. So all you're left with is 0 plus cosine x, which is cosine x.
But couldn't you just leave it that way? Because cosine h over h is 1.
How is cosine h over h 1?
Isn't it? Because that's why you do the minus 1, isn't it? That's what it comes down on my calculator.
What? Cosine h, just cosine h.
Over h, because h approaches 0, it becomes 1 on my calculator.
It should not. You'll have to show me on your calculator. I should not do that. As h goes to 0? Because what is cosine of 0? 1. On top, what's the bottom going to? This is fixed over 0. This is either going to be infinite or negative, infinity, negative infinity, or does not exist. All right, where are we doing on time? Got 20 minutes? Okay, I've proven those to you. I think that's good enough. Right, I could keep on going. I could prove more and more of these just for fun, but we will stop. Exam time, let's talk. And for this, I'm going to turn the camera off. Well, in case some other students ever watch these videos, I'm not sitting there talking